Why is logistic regression called regression if it's used for classification? Logistic regression is called regression because it uses regression techniques to estimate the relationship between input variables and the log odds of an outcome. While its primary use is for classification tasks, the process involves predicting a continuous probability value between 0 and 1, which is then used to classify data into categories. That can logistic regression be used for regression tasks? Why or why not? No, logistic regression is not suitable for regression tasks because its goal is to predict probabilities for classification, not continuous values. Its output, a probability, is bounded between 0 and 1, making it unsuitable for regression problems that require unbounded continuous predictions. What is the main difference between logistic regression and linear regression? The primary difference lies in the type of task they solve. Linear regression predicts continuous values and assumes a linear relationship between inputs and output. Logistic regression, on the other hand, predicts probabilities for classification tasks using a sigmoid function to map predictions to values between 0 and 1. Why is logistic regression considered a probabilistic model? Logistic regression is considered a probabilistic model because it estimates the probability of an observation belonging to a particular class. These probabilities, derived using the sigmoid function, allow for classification based on a decision threshold 0.5. How does logistic regression handle binary classification? For binary classification logistic regression models the probability of one class AG1 using a sigmoid function. The decision boundary, often set at 0 and 5, determines the predicted class by comparing the output probability to this threshold. Probabilities above the threshold are classified as 1 and those below as 0. What is the function Ken? What is the loss function used in logistic regression and why is it preferred? Logistic regression uses the log loss or cross entropy function. It is preferred because it penalizes predictions that are far from the true label more heavily, encouraging the model to produce probabilities that are closer to the observed outcomes. This ensures better optimization for classification tasks. Applying faces that can. What is the activation function in logistic regression and what role does it play? The sigmoid function is the activation function in logistic regression. It transforms the linear combination of input features and coefficients into a probability value between 0 and 1. This allows the model to make predictions suitable for classification. Why does logistic regression use the log odds transformation? Logistic regression uses the log odds transformation to relationship between input variables and the outcome. By modeling the log odds instead of the raw probabilities, the model can use a linear equation to predict probabilities effectively. How are the coefficients in logistic regression estimated? Coefficients in logistic regression are estimated using maximum likelihood estimation. MLE finds the values of the coefficients that maximize the likelihood of the observed data, effectively fitting the model to the training data. What assumptions does logistic regression make about the data? Logistic regression assumes a linear relationship between input features and the log odds of the outcome, no multicollinearity among the input variables, independence of errors across observations, that the classes are mutually exclusive and collectively exhaustive. What metrics can be used to evaluate a logistic regression model? Metrics like accuracy, precision, recall F1 score, and AUC can evaluate the performance of a logistic regression model. AUC-ROC is particularly useful for imbalanced datasets as it evaluates the model's ability to distinguish between classes. How does logistic regression handle imbalanced datasets? Logistic regression may struggle with imbalanced datasets as it tends to favor the majority class. Techniques like resampling, oversampling the minority class, or undersampling the majority class using class weights or optimizing for metrics like F1 score can help address this issue. What is the impact of outliers on logistic regression and how can they be addressed? Outliers can disproportionately influence the coefficients in logistic regression, leading to skewed predictions. Address this by detecting and removing outliers, using robust regularization techniques, or applying transformations to reduce their impact. Hugging Face scan, how do you interpret the coefficients of a logistic regression model? The coefficients in logistic regression represent the change in the log odds of the outcome for a 1 unit increase in the corresponding input variable, keeping other variables constant. Faces that can, they indicate the strength and direction of the relationship between each predictor and the outcome. What is Merticus logistic regression and how is it implemented? Multiclass logistic regression extends binary logistic regression to handle more than two classes. It is often implemented using the 1vs rest hangover approach, where separate binary models are trained for each class or using the softmax function to model probabilities for all classes simultaneously. What is spaces that can? What is the difference between binary and multinomial logistic regression? Binary logistic regression is used for two classes, while multinomial logistic regression handles scenarios with three or more classes. Multinomial logistic regression often uses the softmax function to compute probabilities for all classes at once. How does logistic regression handle categorical predictors? Categorical predictors are converted into numerical values through encoding techniques like one-hot encoding or dummy variables. These encoded values are then used as input features in the logistic regression model. What role does regularization play in logistic regression? Regularization prevents overfitting in logistic regression by penalizing large coefficients. L1 regularization, Lasso encourages sparsity by setting some coefficients to 0, while L2 regularization shrinks all coefficients proportionally. Why can logistic regression use the ordinary least squares, that's OLS method, for optimization? OLS minimizes squared errors, which is unsuitable for logistic regression because its outputs are probabilities, not continuous numerical values. Instead, logispace statistic regression uses maximum likelihood estimation (MLE) or gradient descent for optimization. What are the limitations of logistic regression? Logistic regression assumes a linear relationship between inputs and log odds, struggles with non-linear data, and can be sensitive to outliers and multicollinearity. It doesn't perform well with high dimensional or imbalanced datasets. When would you avoid using logistic regression? Avoid logistic regression when the data shows non-linear relationships, contains a large number of irrelevant features, or is highly imbalanced. Other models like decision trees or ensemble methods may perform better in these cases. What techniques can be used to make logistic regression handle non-linear relationships? To handle non-linear relationships, you can create interaction terms or polynomial features, use kernel methods, or combine logistic regression with feature transformations like PCA or splines. Faces that, and how does logistic regression compare to tree-based models for classification tasks? Logging phase-based logistic regression is faster, simpler, and easier to interpret, especially with linear data. LHS that tree-based models handle non-linear relationships and feature interactions well, but are more complex and harder to interpret. What is the decision threshold in logistic regression, and how does changing it affect the model? The decision threshold (NEG) 055 determines the boundary for class predictions. Lowering the threshold increases sensitivity recall, while raising it improves precision, allowing trade-offs based on the problem requirements. What is the relation space? Is the relationship between logistic regression and maximum likelihood estimation (MLE). Logistic regression uses MLE to estimate coefficients. LLE finds the coefficient values that maximize the likelihood of observing the actual class labels given the input data, ensuring a good fit. How does the gradient descent algorithm optimize logistic regression? Gradient descent minimizes the log loss function by iteratively updating coefficients. It moves in the direction of steepest descent negative gradient to reach the optimal values for the coefficients. Hugging face spaces that can. What is the difference between a probabilistic model like logistic regression and non-probabilistic classifiers? Probabilistic models like logistic regression output probabilities, enabling confidence as estimate and flexible decision thresholds. Non-probabilistic classifiers like SVM directly assign class labels without probabilities. How do you handle overfitting in logistic regression? Overfitting can be managed using regularization L1 or L2, reducing the complexity of the model by removing irrelevant features, or validating the model with techniques like cross-validation. Why is logistic regression sensitive to outliers and how can it be robustified? Outliers can disproportionately affect the coefficients skewing predictions. Address this by detecting and removing outliers, applying robust regularization, or transforming variables to reduce the effect of outliers. What are some real world applications of logistic regression? Logistic regression is widely used in credit scoring tier to predict loan default risks, healthcare disease diagnosis, marketing, customer churn prediction, and fraud detection, classifying transactions as fraudulent or not.